collections.abc. Abstract base classes for containers. Source code lib underscore collections underscore abc py. This module provides abstract base classes that can be used to test whether a class provides a particular interface. For example, whether it is hashable or whether it is a mapping. An is subclass or is instance test for an interface works in one of three ways. A newly written class can inherit directly from one of the abstract base classes. The class must supply the required abstract methods. The remaining mixin methods come from inheritance and can be overridden if desired. Other methods may be added as needed. Class C sequence init, get item, len and count method. Is subclass C sequence true? Is instance C sequence true? 2. Existing classes and built-in classes can be registered as virtual subclasses of ABCs. Those classes should define the full API including all of the abstract methods and all of the mixin methods. This lets users rely on is subclass or is instance test to determine whether the full interface is supported. The exception to this rule is for methods that are automatically inferred from the rest of API. Class D init get item length count index sequence.register D register instead of inherit. Is subclass D sequence true? Is instance D sequence true? In this example, class D does not need to define constants, iterator, contains iterator reversed because the in operator and iteration logic and reversed function automatically fall back to using get item and len. Some simple interfaces are directly recognizable by the presence of the required method unless those methods have been set to none. Class E iterator and next method. Is subclass E iterable? True. Is instance E iterable? True. Complex interfaces do not support this last technique because an interface is more than just the presence of method names. Interfaces specify semantics and relationships between methods and cannot be inferred solely from the presence of specific method names. For example, knowing that a class supplies get item, len and iterator is insufficient to distinguish a sequence from a mapping. Collections abstract base classes. The collection module offers the following ABCs. ABC inherits from abstract methods, mixin methods. Container contains abstract method. Hashable has abstract method. Iterable hash method. Abstract method. Iterable inherits from iterable. Next abstract method iter mixin method. Reversible iterable underscore underscore reverse underscore underscore abstract method. Generator iterator send and throw abstract methods. Close iter next mixin method. Sized length abstract method. Callable call iterator abstract method. Collection sized iterable container contains iterator length. Sequence reversible collection get item length contains iterator reverse index count. Mutable sequence get item set item delete item len insert. Inherited sequence methods and append reverse extend pop remove and add. Byte string sequence get item length inherited sequence method. Set collection contains iterator length le less than or equal to less than equal not equal greater than or equal to and or sub XOR and is disjoint. Mutable set contains iterator length add discard. Inherited set methods and clear pop remove IOR I and I XOR and I sub. Mapping collection get item iterator length contains keys items values get equal not equal. Mutable mapping get item set item delete item iterator length. Inherited mapping methods and pop item clear update and set default. Mapping view sized length items view mapping view set contains iterable keys view, mapping view set, contains iterator. Values view, mapping view collection, contains iterator. Awaitable, await, coroutine, awaitable, send, throw, abstract methods, abstract class methods, and close. uh, Async iterable, AITER, async iterator, async iterable, A next, AITER, async generator, async iterator, ascend, as throw, A close, A iterator, A next, buffer. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. These abcs override subclass hook method to support testing an interface by verifying the required methods are present and have not been set to none. This only works for simple interfaces. More complex interfaces require registration or direct subclassing. Checking is instance object iterable detects classes that are registered as iterable or that have an ITER method, but it does not detect classes that iterate with the getItem method. The only reliable way to determine whether an object is iterable is to call ITER object. Collection abstract based classes detailed description. Class collections.abc.container, abc for classes that provide the contents method. Class collections.abc.hashable, abc for classes that provide the hash method. Class collections.abc.sized, abc for classes that provide the length method. Class collections.abc.callable, abc for classes that provide the call method. Class collections.abc.iterable, abc for classes that provide the ITER method. Checking is instance object iterable detects classes that are registered as iterable or that have an ITER method, but it does not detect classes that iterate with the getItem method. The only reliable way to determine whether an object is iterable is to call ITER object method. Class collections.abc.collection, abc for sized iterable container classes. Class collections.abc.iterator, abc for classes that provide the ITER and next methods. See also the definition of iterator. Class collections.abc.reversible, abc for iterable classes that also provide the reversed method. Class collections.abc.generator, abc for generator classes that implement the protocol defined in PEP 342 that extends iterators with the send, throw, and close methods. Class collections.abc.sequence, class collections.abc.mutable sequence, class collections.abc.byte string, abcs for read only and mutable sequences. Implementation note: some of the mix-in methods such as ITER, reversed, and index make repeated calls to the underlying getItem method. Consequently, if getItem is implemented with constant access speed, the mix-in methods will have linear performance. However, if the underlying methods is linear, as it would be kind a linked list, the mix-in will have quadratic performance and will likely need to be overridden. Class collections.abc.set, class collections.abc.mutable set, abcs for read only and mutable sets. Class collections.abc.mapping, class collections.abc.mutable mapping, abcs for read only mutable mappings. Class collections.abc.mapping view, class collections.abc.items view, class collections.abc.keys view, class collections.abc.values view, abcs for mappings, items, keys, and values views. Class collections.abc.awaitable, abc for awaitable objects which can be used in await expressions. Custom implementation must provide the __await method. Coroutine objects and instances of the coroutine abc are all instances of this abc. In C Python, generator based coroutines, generators decorated with @types.coroutine are awaitable even though they do not have an await method. Using is instance gen_coro awaitable for them will return false. Use inspect.isAwaitable to detect them. Class collections.abc.coroutine, abc for coroutine compatible classes. These implement the following methods defined in coroutine objects: send, throw, close. Custom implementations must also implement await method. All coroutine instances are also instances of awaitable. Note in C Python, generator based coroutines generators decorated with types dot coroutine are awaitables even though they do not have an await method. Using is instance gencoro coroutine comma coroutine for them will return false. Use inspect dot is awaitable to detect them. Class collections.abc.async iterable abc for classes that provide an iterable method. See also the definition of asynchronous iterable. Class collections.abc.async iterator abc for classes that provide a iter and a next method. See also the definition of asynchronous iterator. Class collections.abc.async generator ABC for asynchronous generator classes that implement the protocol defined in PEP 525 and PEP 492. Class collections.abc.buffer ABC for classes that provide the underscore underscore buffer underscore underscore method implementing the buffer protocol. See PEP 688. Examples and recipes. ABCs allow us to ask classes or instances if they provide particular functionality. For example, size is equal to none. If inheritance, my variable collections.abc.sized size is equal to length of my var. Several of the ABCs are also useful as mixins that make it easier to develop classes supporting container APIs. For example, to write a class supporting the full set API, it is only necessary to supply the three underlying abstract methods contains, iterator, and length. The ABC supplies the remaining methods such as underscore and is disjoint. Class list based set collections.abc.set alternate set implementation favoring space over speed and not requiring the set elements to be hashable. Diff init iterable self dot elements is equal to lst is equal to blank list. For value in iterable, if value not in list dot append value. Diff iterator self return iterator self dot element contains return value in self dot elements length of self dot elements. S1 dot list based set a b c d e f. S2 list based set d e f g h I overlap is equal to S1 and S2. Example, collections.abc from collections import collections.abc dot set as from collections.abc import set okay. S1 is equal to list by abc list by abc. Now print overlap for overlap def A नहीं है, B is inside that, C is not present, D is present in both, E is present in both, F is present, G, H, I is not, so that's why it is ABC. Overlap is equal to S1 or S2 print dot join overlap def Okay. Overlap is equal to S1 X or S2. Print blank dot join overlap ABCGHI. Notes on using set and mutable set as a mixin. Since some set operations create new sets, the default mixin methods need a way to create new instances from an iterable. The class constructor is assumed to have a signature in the form class name iterable. That assumption is factored out to an internal class method called from iterable, which calls cls iterable to produce a new set. If the set mixing is being used in a class with a different constructor signature, you will need to override from iterable with a class method or regular method that can construct new instances from an iterable argument. To override and comparisons, presumably for speed, as the semantics are fixed, redefined less than or equal and greater than or equal, then the other operations will automatically follow suit. The set mixin provides a hash method to compute a hash value for the set. However, hash is not defined because not all sets are hashable or immutable. To add set hashability using mixes inherit from both set and hashable. Then define underscore underscore hash is equal to underscore set dot underscore hash. Ordered set recipe for an example built on multiple set. For more about ABC, see the ABC module and PEP 3119. Thank you.